Thank you, Julie and Candace, for that nice introduction. So quickly, I'm just going to be talking about an overview of citizen science, some examples or models of citizen science, and some of the research that I've been involved with on outcomes, and then some more current research that I'm working on, looking at water quality monitoring in particular, comparing those kinds of projects with other types of citizen science projects. So as Julie mentioned, I'm at the Cornell Lab of Ornithology. We are a membership institution, and citizen science is right there in our mission statement. We've been involved in citizen science since the mid-1960s. But, you know, what exactly is citizen science? It really kind of depends on where you sit, where you stand. Some people consider it a field. Some people think of it more as a methodology. Some people consider it a hobby, others a very useful tool for gathering data. So depending on where you are, it could have a slightly different meaning. I'll offer a couple of definitions here. This is one that just became official in the Oxford English Dictionary in 2014. Citizen science as scientific work undertaken by members of the general public, often in collaboration with or under the direction of professional scientists and scientific institutions, which we thought when we saw that that's pretty good. We agree with that. I also found this definition in a listing under citizen scientists in the Oxford Dictionary, which I just thought was kind of amusing, if not slightly provocative, the idea of the amateur investigator who in the past contributed substantially to the development of science through part-time dabbling. And that was from 1979. So the idea of citizen science is not necessarily new, but certainly it's evolved over time. The definition that we use more frequently now at the Lab of Ornithology is members of the public and professional scientists engaged in collaborative research to generate new science-based knowledge. So Julie had asked me to describe some different ways that citizen science is sort of examined or studied. This is a table that Andrea Wiggins provided. I thought it was kind of useful just to see the sort of great diversity in the kinds of things that are very similar to citizen science. And this table provides some key features of these different types of activities where the public engages in science, and also the primary discipline or research domain that they occur in. So the two that we'll be focused on in this conversation is the one that we're labeling as citizen science and volunteer community-based monitoring. Other people have studied citizen science in terms of typologies, so what are the characteristics? And these can also be sort of sliced and diced in many different ways. Participation levels, the functional approach that people use to operationalize the activities that people do, typologies based on goals and tasks. So this is not an exhaustive list. There's people studying this from so many different interdisciplinary domains, but the one that I'll be talking about throughout this talk is the one that's bolded. That's the contributor, collaborative, and co-created model of citizen science. This idea came about in 2009. We actually worked very closely with Candy Wilderman, who was the director of ALLARM, to come up with this typology that really was based on the participants' involvement in the scientific process. And so for those projects that are labeled sort of contributory, the participants are there mainly collecting data or samples and sometimes analyzing and sending off those samples. In a more collaborative approach, the participants are engaged a little bit more deeply, perhaps designing data collection methods or protocols in addition to collecting data, and perhaps even analyzing data. And then in the co-created model, which is what I consider a lot of the water quality monitoring and also air quality monitoring types of programs to sort of self-describe as, it's more of a co-created where the participant is involved in almost every phase, if not every phase, of the scientific process, from defining the question or the issue to disseminating information and continuing the research agenda. So although we tend to think of citizen science as a fairly new phenomenon, it is worth noting that it's been going on formally for over 100 years. There's actually records of citizen science happening over 1,000 years ago in Japan, where people used to take note of the cherry blossom events that occurred on a year by year, and some even think of it as a way for us to actually look back on climate change and how the climate has changed using those early records. So it's been going on for a really long time. With the projects that are currently in existence, I would say that citizen science has become much more formalized in the last 20 years. When I first started in this realm about 18, 19 years ago, there were a couple dozen projects. Largely, most of them were actually water quality monitoring projects and a few other projects looking at other kinds of natural phenomenon. Now there are hundreds, actually there are thousands of citizen science projects. You can go to scistarter.com where they have at least 1,500 or 1,600 citizen science projects around the world. So there's really been nothing short of an explosion in the variety and the numbers of projects and people engaged in citizen science. So clearly there's a huge interest. One of the things that we've seen even in the last 5 years is the growth of citizen science as a field. There are international conferences that happen annually now. So many special issues in leading journals, so the entire issues of these really top-notch journals being devoted to citizen science. There's an estimate of 1,500 plus papers using citizen science data. That graphic on the bottom of the screen really shows the sort of exponential growth in peer-reviewed publications using citizen science data. The White House has presented and offered several recognition events of citizen science, and now they're actually mandating citizen science in a lot of their programs. There's a federal community of practice. There's a new journal that's called Citizen Science Theory and Practice, and then of course there's the Citizen Science Association, which is currently free to join. I know Chris is going to talk a little bit about the association. I just wanted to point out that just yesterday, I believe it was, the call for abstracts for the 2017 conference just came out. So this is happening next May in St. Paul, Minnesota, and we really hope that the water quality community is greatly represented at this conference. So we've had one citizen science conference in San Jose, California, and it was attended by about 600, maybe 700 people, so we expect this one to be even bigger. So I'm going to pivot my talk now just a little bit to describe more of what I do specifically in the public engagement and science program at the Lab of Ornithology. So we do a lot of work in designing, evaluating, and researching projects that engage the public in scientific research and conservation. We also do a lot of field building and professional development. I'm going to focus a little bit more on this piece of conducting research on outcomes of citizen science that I've been involved in. One of the things that I'm sort of wrapping up this effort, this was an NSF-funded project called devised, which stands for Developing, Evaluating, and Validating Implementing Situated Evaluations in Citizen Science. This project was really in an effort to build evaluation capacity for the field, and it was focused on individual learning outcomes. There's a really easy-to-use user's guide, public participation in scientific research, user's guide for project evaluation that's free and downloadable from the citizenscience.org website. And it provides a lot of tips and templates and recommendations for doing quality evaluations. We've also created a whole bunch of survey instruments for measuring things such as interest in science and nature, self-efficacy, motivation, skills of science inquiry, and environmental stewardship. So these are the commonly named outcomes that project leaders across the field have said they are really interested in influencing with respect to individual participation. You may have noted I didn't say we have instruments or surveys for the knowledge of nature of science. We're still struggling with that one, but you can also go to that website to find and download the instruments for free if you're interested in measuring any of those kinds of learning outcomes. We've done a lot of work in the area of research outcomes. So I mentioned before, over 1,500 citizen science papers. That's just one of the ways that we can measure the outcome and the research potential of citizen science. There's a whole list of other things that people are looking at, everything from publicly available data sets to data actually being used to inform management decisions and regulations, which is something that we just wrote about in a biological conservation paper using eBird data and showing over 150 different uses of the data in a conservation application. Again, there's also a whole lot of people that are studying the policy and conservation outcomes of citizen science. There's a really nice issue, a really nice special issue here from Issues in Ecology that looks at how agencies can invest in citizen science to improve natural resource management. I would encourage you all to download this special issue. It's really got a lot of information, and there's also quite a bit of representation from the water quality community in that as well. And I want to say that people are looking at community outcomes. I would, however, underscore that this is sort of the place where we can use the most work. The area is ripe for really starting to look at what are those community outcomes like social capital, economic impacts, environmental justice, resiliency, that citizen science can influence on scales of the individual all the way on up to society and ecosystems. So the complexity in looking at something like this is great, which is why it's probably the hardest nut to crack. But there are a lot of people that are interested in this. I personally am really interested in this, so I think we'll be seeing a lot more of these kinds of studies and investigations to really try to understand better the role of citizen science in communities. So now I'll just talk real briefly for the rest of my time here on my current project, which is a collaborative research project with UC Davis, Heidi Ballard, who's the other collaborator, and Rick Bonney, who's the PI of this project. So we are exploring engagement and science identity through participation. We call this project ESTEP for short. It's basically a project that's looking at the intersection between citizen science engagement, learning, and science identity. So we have three major research questions. The first one is a very qualitative kind of question. What are the dimensions of science engagement across different projects, and how do we quantify it? The second question is more quantitative in nature, trying to understand what is the relationship between how one engages and their learning outcomes. And then the third is qualitative, and it's a longitudinal look at how does the degree and quality of participation influence an individual's science identity. So I'm going to be focused on providing you with some preliminary data from this first question. So our project partners span that continuum of the contributory to collaborative to the co-created model. You can see these are the 6 projects that we are involved with, and the Alliance for Aquatic Resource Monitoring, affectionately called ALLARM, they are one of our 6 projects. So we have 2 projects that are contributory, 2 projects that are collaborative, and 2 projects that self-identify as co-created. And with these 6 projects, the first research question is looking at the dimensions of engagement. So I'm going to provide you with some really early preliminary data on the interviews that we did in this phase 1 project. So for the first phase, we interviewed people across these 6 projects, and specifically to ALLARM. We had 10 ALLARM participants. These were very in-depth interviews. We asked them about their engagement, their motivations, their barriers to participation, and the kinds of activities that they did. They tended to last about an hour and a half. And so I'll just provide some of the quick data from this. Julie had asked that I show sort of ALLARM, what ALLARM participants say compared to the other 5 projects. And so these graphics basically show motivations to participate. Not surprising, the #1 motivation for ALLARM participants to participate is water quality issues. Obviously, that doesn't come up with the rest of the projects. But the other most common motivations are contribution, this idea of a place-based motivation to be near a local environment that there is some sort of affection for, and there's also a lot of social reasons that people participate. And so you can see, yes, there are a huge variety of motivations, but in addition to water quality, the ALLARM folks are very much in line with the other projects in terms of their wanting to contribute, wanting to be doing something locally, and they're wanting to be socially engaged with others. When it comes to barriers to participation, for all projects, it was time, and we kind of figured that. For ALLARM, weather was one of the biggest barriers to participation, which again makes sense. You guys are out there in the middle of winter sometimes, and bad weather in streams up to your waist, so it's not a surprise. Weather, time, and data transparency were the 3 most common barriers to participation out of the 10 people that we interviewed for ALLARM. And you can see there's other things that don't show up in ALLARM at all, like things like disease or ticks or feeling isolated or safety risks or no data to report. So those show up in other projects and they don't show up as barriers to ALLARM. Some of the suggested learning outcomes, so we asked people, what are you learning? How are you learning? This was sort of consistent across all the projects. People are learning through the experience. This came through really, really strongly across everyone that we spoke to. They are learning a lot of new information. A lot of people came in with a ton of pre-existing knowledge. A lot of people spoke about this idea of increased awareness of the ecosystems around them, and then also learning about science process and citizen science. Some of the project activities that people actually do. So the top 3 activities, it was kind of amazing, were consistent across all the projects. So data collection was #1. Communicating with others was #2, and learning protocols was #3. And that was consistent across all the projects. I guess it's not all that surprising, but they are so different in scope and in nature that I did find it a little surprising. But one of the other things that ALLARM folks do is communicating findings to others. That was huge. Attending meetings, submitting data reports, and using standardized methods. So these are the more common things that ALLARM folks do relative to all of the other projects that we looked at. And I will just end. I know I've got about a minute left. I will just end with some of the memorable quotes from ALLARM because I think these are really powerful. I won't read them because they're quite lengthy. I'll let other folks read them. But they do suggest, they do provide sort of the insight in the kinds of powerful outcomes that every project leader hopes to see. So the first person is talking about all of the learning that suddenly they realized they were getting access to. I love the line where it says, all of a sudden it was like, Horton, here's a who. You realize there's so much you don't see that's part of the food chain. It's a really nice example of learning and increased awareness. The second quote is really about this individual had these skills, but they were sort of buried, and we heard that over and over, that people, they sort of had this science niche that they were a part of, or that they always wanted to be a part of, or that they used to do in their youth, and these projects really help to bring that back into their life and really provide them with that sense of belonging and contribution. And so this person was really talking about really just needing a little push, a little honing for those skills to come back into his life. And then, oops, sorry, that last one, lost that last slide. That last one was really about behavior change empowerment. I think that if you ask most project leaders, if there's one thing that they hope to influence, is this idea of behavior change. And in particularly with ALLARM, it's the idea of that if you have data, you have power. Data gives you a voice to be heard. And we heard this so often from, particularly from the co-created projects, from the ALLARM participants and the air quality participants that we spoke with. So just really powerful kinds of examples of the kind of influence that citizen science engagement can have on individuals in their everyday life. And so with that, I will hand it over to Chris.
Represent in peer-reviewed journals how often this term would show up. So volunteer monitoring comes up somewhere around in the middle to the lower half of where I was seeing the term show up. And I really feel like that has to do with the way that volunteer water monitoring, or volunteer monitoring for short, comes into being and how where its history lies. And that is in, for some reason the slides are not advancing. There we go. So that's in the natural resources and the environment, and not being able to, wanting to protect our natural world. There was water quality issues here in the 1960s. Some of these still remain today. And the classic, the Cuyahoga River on fire in 1969. So as a result of these kinds of environmental disasters, many of which have to do with water quality, a number of federal laws were passed in the 1970s that had to do with the environment and water quality. The most important of those was for volunteer water monitoring, the Clean Water Act, which was passed in 1972. And the Clean Water Act came with it a goal of having all of the nation's waters fishable and swimmable. And it also came with a mandate for states to assess and report to the federal government how waters of each state were doing as far as being polluted or being healthy. And along with this, around the same time, there was a shift in how decisions were being made by organizations, by federal government, by state governments. And there was really a big push to encourage public participation so that there wasn't top-down control, and instead there was participation by the public in decision-making and natural resources management decision-making. So with these policies and with the shift in how public decisions were being made, that really set the stage for volunteer monitoring to become something strong and something that's happening in many local communities. So what we saw is that in the 1970s, a number of volunteer water monitoring programs were established. And that's only continued to grow since the 1970s. Today, we estimate about 1,675 volunteer water monitoring programs operating across the United States. And one of the things that I did a couple of years ago, I did a national survey of all the volunteer water monitoring programs that I could find, and asking the volunteer monitoring coordinators to answer a number of questions about how their programs are designed, the program characteristics, as well as the outcomes that these programs have had for natural resources policies and management. And one of the components of that survey was to try to understand how they fit into this co-created, contributory, collaborative topology that Tina was talking about previously. So this table shows how I analyze and ask questions. One of the key things, and Tina saw this as well, is that the volunteers in these programs are collecting data. So that was a given. I only counted them as a volunteer monitoring program if volunteers collected data. So all programs collect data by volunteers. The contributory programs were designed, the protocols were designed, the data are analyzed, and the results communicated solely by paid staff or scientists, whereas the volunteers were not engaged in that. For collaborative programs, the volunteers might have another role besides data collection, whether that be designing protocols, analyzing data, or communicating results. And then the paid staff would have all of those roles still. For co-created programs, volunteers and staff have all of these roles, designing protocols, analyzing data, communicating results. And then the collegial programs are those that are led by the volunteers, and then scientists and paid staff are not playing these roles. So what I found is that most of the volunteer water monitoring programs in the country, 53%, are actually collaborative programs. So again, looking back, that's where volunteers are playing some role besides just data collection, but not necessarily every other kind of role, the designing protocols, analyzing data, communicating results. And about 30% are contributory, where I would tend to think that more of the citizen science programs are contributory, where scientists are designing the scheme and having volunteers contribute data for that analysis. So to give you a little bit more information about these volunteer water monitoring programs, I wanted to talk about where they're monitoring. So most of them, the majority, are monitoring streams. About half, just under half, are monitoring lakes. And then fewer percent of these programs are monitoring in marine or estuary environments, wetlands, beaches, or groundwater. Most of the programs, and I think this relates to how the Clean Water Act mandates how water quality data are collected, most of the programs are operating in small, either a single local water body or in a single watershed, or something where there's multiple watersheds, but it's still within a local area, not on a statewide, regional, or national scale. Only about 1 in 5 programs is operating on a statewide level, and only about 1% of programs operates nationally. One of the things that we wanted to make sure was clear about volunteer water monitoring programs is that they're very focused on ensuring that good quality data are collected. A lot of them, and it depends on their goals. Some of the programs are out there looking at doing education in schools, so they might be not as focused. But many of the programs do have stringent quality assurance and quality control measures. For instance, requiring that people go to training, doing side-by-side monitoring with the volunteers, collecting replicate or duplicate samples, having data ranges where the volunteers would know that if they were outside of a range, they should recalibrate the equipment, always calibrating the equipment before they monitor, making sure the data are complete, setting monitoring dates ahead of time, and making sure that they collect those data on every single planned occasion, and if not, having a reason or flagging the data if all of the data were not collected. So these programs have a lot of different things that they're putting into action. One of the ways that they do this is by developing what's called a quality assurance project plan. And so programs that are funded by the EPA are required to have a quality assurance project plan, but other programs are not, but they can. What a quality assurance project plan, or QAP, does is define how often volunteers are trained, how they'll be trained, when they'll be trained, how the data will be quality controlled and quality assured, kind of the things that I was just talking about. And it's all written down, and it's signed in certain cases where the state, if it's a state agency, they might approve the quality assurance project plan, or if it's EPA-funded project, they would approve it, or if a program wants, they would work with EPA to get that approved. So this gives you the lay of the land of the population of volunteer water monitoring programs in 2013. 20% of programs had no formal quality assurance plan. About 70% had written methods, which is great. I'm actually surprised that it wasn't higher than that. About 40% had state-approved quality assurance project plan, and about a quarter had EPA-approved project plans. So in terms of the outcomes that these programs shared with me through this survey, I categorized those into 4 areas. So the volunteer data were used to impact natural resource management decisions, such as closing a beach or opening a fishing area because the data proved that there was a concern that the water was good enough quality. Volunteers became civically engaged. There was some kind of organizational change at the agency level as a result of volunteer monitoring, and that water bodies were protected or restored. So I asked a series of about 20 questions, and for each question, if saying, had volunteer data been used to fill in the blank, if somebody would answer yes, then I would ask them to share a vignette. So I have many, many pages of stories and examples of how the volunteer data were used to do these variety of things. But what I'll show you today is the percents of programs that reported these different kinds of results. So this first one, so volunteer monitoring has impacted water quality, water body protection and restoration. The most common thing that resulted in programs is that with volunteer data, that program was able to obtain funding to protect or restore a water body. And the kinds of things that would happen would be maybe a repairing buffer was put in, or able to either replace or install a buffer. That's the most common example. Other types of results using data to justify altering a land use. So maybe there was some way that the land was used, like cattle access, putting in cattle access sites. Is another comment. About 40% of programs had that as a result. In terms of the kinds of results for volunteer monitoring impacting natural resource management decisions, this really, again, links back very often to the Federal Clean Water Act and the kind of mandates of what states need to report about the water bodies in the state. So the number one way that volunteer monitoring programs have impacted natural resource management decisions is by identifying where a water quality standard was not being met. 70% of programs have done this. There's an acronym here called a TMDL. So what that is called a total maximum daily load, and states are required to say if a water body is being polluted, needs to identify what the total amount of pollutant that water body can receive before being polluted, before being considered clean. So a TMDL defines the pollutants and the level at which it needs to be minimized to be considered not polluted, and then an implementation plan is put into action to clean that water body up. So about 40% of programs were monitoring for TMDL, which had already been established to see how things were going, and about 30% had been involved in collecting data that were used to develop the total maximum daily load. The most often kind of outcome that volunteers or volunteer monitoring programs reported was that volunteers had become engaged in civic issues related to the environment. So 83% of programs reported that their volunteers had attended some kind of natural resources related public meeting after becoming volunteer monitors. About 60% of programs reported their volunteers had served on a natural resources board, and I'll tell you, the vignettes that were shared, I think the volunteers have served on every kind of planning commission and conservation commission, and as mayors and every kind of board in a community that you could come up with. I think a volunteer monitor has served on that. The volunteers have also written letters with and without data to support or refute proposed policies about the environment, and a number of programs reported testifying before legislative bodies, including 3 programs that were testified before Congress as related to the waters that they were monitoring and their will and interest to have those bodies water protected. And then the last category is where volunteer monitoring has resulted in changes for organizational activities. So the most often reported outcome here is that citizens were given staff responsibilities. So about 55% of programs where, for instance, in the program I used to coordinate the volunteers for our stream monitoring program in Wisconsin, were given, if we could find volunteers from our program who were trained and willing, all of the phosphorus samples collected in the state of Wisconsin in streams were collected by volunteers to free up time of the biologists. And in that state, we saved about $12,000 in travel for the biologists and really freed up their time to work on other activities as opposed to collecting the phosphorus samples. So looking at these organizational changes where an organization might have become aware of a concern, pollutant concern, and changed where they were monitoring, that happened in about 42% of programs. So the way that I look at it, volunteer monitoring and all these other terms all are kind of like a big messy Venn diagram where they all feed into the citizen science of the public participation in scientific research, and many of them will have unique characteristics like volunteer monitoring with its history in the environment and in management and understanding what's happening to local environments and people having individual personal concerns about the quality of the water that they live near, recreate on or in, and each of these other types of citizen science probably has their own unique things, but feeding together into this realm of citizen science. So as Tina mentioned, I was going to talk a little bit about the Citizen Science Association. This association was formed in 2014, so it's a fairly young organization. Where we're looking at creating a world where people understand, value, and participate in science. And our mission is to advance this field of citizen science through communication, coordination, and education. I'm one of the board members for this association, feeling like I have a good connection with the volunteer monitoring world and bringing that into this Citizen Science Association. So we have this global community of practice, which I'll share with you in a minute about how big the program is now and the association is, where we're working to share program values and impacts and share best practices among programs and practitioners and researchers and evaluators, and trying to advance the field internationally, across state borders and country borders and beyond, and being able to provide networking and professional development for programs, as well as supporting diversity and inclusion for as many who we can get to be able to participate. Currently, we have over 4,000 members from 80 countries, and membership is free. So if you are interested, check out citizenscience.org. As Tina mentioned, we have the conference May 17 to 20 next spring, and we have abstracts. The call for abstracts is out until early October. I also wanted to share there are a number of ways to be able to communicate across the volunteer monitoring world as well as the citizen science world. And there's a half a dozen listservs that are available. The EPA Volunteer Water Monitoring Listserv has over 500 members who are represent a lot of state agencies, federal agencies, nonprofits, and school volunteer water monitoring programs. The Extension Volunteer Monitoring Network has over 400 members, most of whom are related to the University Extension Service and water monitoring and water programs of extension across the country. The Citizen Science Association has a listserv with thousands of members. It's a very active listserv talking about research and the theories and big picture issues, 10,000-foot view down to local questions, if you will, how to run these programs. Very active list. The Federal Community of Practice on Crowdsourcing and Citizen Science is open to people with emails that are .gov or .mail, and it's intended to help federal entities operate, design, and facilitate over the long-term citizen science projects. Both NOAA and E-Extension, which is related to University Extension, have community practices for citizen science as well. And what I did is I put all of the directions for how to join these listservs on a website that I maintain because the slide was getting a little bit busy. So this website that's shown here, volunteermonitoring.org/resources, will link you right to information about joining any or all of these listservs. And then the one other thing I wanted to do is to share some websites where you can get information. So for volunteer water monitoring, one of our biggest current umbrella groups we've worked through with EPA and the USDA Cooperative Extension, and now with the National Water Quality Monitoring Council, we have resources on the website there. The website I maintain for volunteermonitoring.org, which began as the Extension Network, EPA was one of the beginners starting points for volunteer water monitoring, and they have a number of methods manuals that are available on their website, as well as a guide for doing quality assurance project plans. Citizen Science Association I've talked about. The federal crowdsourcing group not only has a listserv, but a toolkit to help programs grow and develop for federal agencies. And I wanted to mention that SciStarter.com that Tina also mentioned recently did an update, and they added the ability for water programs to add themselves to SciStarter.com. So it's a listing service for all kinds of citizen science programs, but really putting a push to get the volunteer water monitoring programs to join. I also have a Twitter handle at VolMonitor if you're interested in following what's happening in the world of volunteer water monitoring. And with that, I will turn it over back to questions from all of you.